So we're going to talk about lessons 5.03 and 5.04 because that's what we have this week. Those two lessons are about geometric sequences and series. Last week we had arithmetic sequences and series. Arithmetic is where we have a common difference between each term of the sequence. It may be 2, 4, 6, 8, 10, 12, which is the common difference of adding 2 every time. It might be 10, 7, 4, 1, -2, which is the common difference of adding a -3 or subtracting 3, whichever way you'd like to see that. But now we're going to look at geometric sequences this week. And let's look at a different type of sequence, geometric. Geometric sequence. So a geometric sequence could be, for example, 1, 4, 16, 64, ... All right, so obviously that's not arithmetic, right? It adds 3, then it adds 12, then it adds 48. That is not arithmetic in any way. But what is happening? There is a pattern. What is happening with our sequence here?
It's like getting, like times 4.
Times 4. If we're not sure, we can always work backwards and say, okay, well, let's see, what is 4 divided by 1? If we know it's not arithmetic, we can check and see it. Then what's 16 divided by 4? What's 64 divided by 16? And if all those end up the same, okay, 4 divided by 1 is 4, 16 divided by 4 is 4, 64 divided by 16 is 4. So obviously it is times 4 every time. So this means it's a geometric sequence. Geometric because it's multiplying by the sum number each time. And that's how you check that. Just divide. Because you could have a case where you have 1, 3, 9, 30, ... And when you go to check it, 1 times 3 is 3, 3 times 9 is 3, 9 times 3, oh, that doesn't work. So that's not a geometric sequence because 9 times 3 is 27. So this is not a geometric, this is neither. It's not arithmetic or geometric because it doesn't have a pattern that's consistent all the way through. So we don't know what the next term is. It could be anything, quite honestly. So looking at arithmetic sequence. All right, let's figure out what is, how about this one? What is the next term in that sequence? And that is a geometric sequence, by the way. Mia says it's -81. We have a confirmation of that. Anyone else think it's -80?
That seems right to me.
All right, we have agreement there. So we have to look at our, well, with let's talk about the terminology. We had a common difference with arithmetic, right? The difference when you subtracted the terms, it was the same every time. With geometric, we use R because it's a common ratio. It's a common ratio, R. So we used D for the difference with arithmetic. We use R with geometric. So our common ratio every time. All right, we have lots of confirmation. Lexus and Skylar, thank you. What's happening here is it's multiplying by -3. Multiplying by -3. -1 times -3 is a +3. 3 times a -3 is a -9. -9 times a -3 is a +27. And a +27 times -3 is -81. So that kind of leads to our, just like arithmetic, we have a recursive formula. A recursive formula to figure out what the next term is. And it is a sub n equals the common ratio times a sub n minus 1. Okay, we'll highlight that. So if you're taking notes, that's a wonderful thing for your notes right there. The recursive formula, if we want to know what, in this case, the fifth term is, because I asked you what is the next term, that would be the fifth term. All we have to do is take that common ratio, -3 times n minus 1, n was 5, the fourth term. The fourth term was 27. So as long as we know the fourth term, we can find the fifth term. Just multiply it by the common ratio. So a sub 5 equals -81. That again is the recursive formula. Just like we had a recursive formula in arithmetic, where as long as you know the one before it, you just add the common difference. This one, you just multiply the common ratio. So that leads us to say,
Wait,
okay,
what'd you minus 1 from?
the n.
Oh, it's sub. Okay, just
It's a
kidding.
sub. Yeah, n minus 1 is the sub standard there. So,
Okay.
right. So a to the fifth, that's a to the fourth equals, equals 27. So yeah, n minus 1. The whole minus 1 is a sub there, a sub n minus 1. All right, so that's the recursive formula, which is only useful for the next few terms, right? After that, not so useful, because if we wanted to know what A15 is, we don't want to have to figure the fifth, the sixth, the seventh, the eighth, ninth, 10th, 11th, 12th, 13th, and 14th. That's a lot of work to get to the 15th if there's a better way. And of course there is, right? There is the explicit. There's the explicit formula. That'll take us straight there. So the explicit formula, let me give that to you. We want to know a sub n. As long as we know the first term, a sub 1, multiplied by r raised to the power of n minus 1. R raised to the power of n minus 1. So for a sub 15, we got to have a sub 1 times r. Oh, not a sub 14, just r to the 14th. R to the 14th power. Using our formula, whatever the first term, common ratio raised to the 14th power. So a sub 15, a sub 1, our first term is -1 times r is -3 in this case. -3 raised to the 14th power. We're definitely going to want our calculator for that. So let's pull out a calculator here. So we can calculate, let's see, -3 raised to the power of 14 is 4,782,000. And we need to multiply that times -1. So it's negative. A sub 15 equals -4,782,969. So that saved us a lot of work in getting there. Multiplying by -3, -3, -3, -3. We can use this explicit formula to jump straight to it. So there's the formulas you can use for your notes. It's always good to have some examples next to it, just so you remember how to use that. So let me see, what's another good thing to look at? So what's the things we generally need to know for these? You need to know, of course, a sub 1, if you're going to use the explicit formula. You always need to know n, which is which term are we looking for? Is it the 15th term? Is it the fifth term? What is our n? And that'll automatically give you n minus 1 when you know n. And we need to know a sub n minus 1 if you're using this formula, right? We need to know what the term before the term we're looking for is. And we need to know r. So those are the possible things that you would need to know to find a sub n in either formula. A1, n minus 1, a sub n minus 1, and r. So it really all boils down to r and n and a1 because these are calculated. So if we know that, we can make a lot of progress with that. So let's look at this right here in this situation. You may have some problems, and I'm pretty sure there are some problems that say this. It says, okay, the first term is 6. And the 8th term, a sub 8, I'll raise this up, is equal to negative 468,750. And it's asking you, what is the 14th term? Oh my goodness, how are we going to get that? Let me make that 8 better. That's not a very good 8. Make it bigger. There we go. A sub 8. We're like, wow. Gosh, where do we start? Well, we know that for either formula, we need r, which is the common ratio. What's being multiplied each time in the sequence? Well, having this and this, it's hard to even put a good guess out there, right? The only thing we know for sure right now is our r is going to be negative. Our r is going to be negative. How do we know that? Why do we know the r is going to be a negative number?
Because A8 is a negative.
Right. And A1 is a positive. So if we have positive and negative numbers, we know that R has to be a negative because that's the only way we can jump back and forth is to be multiplying by a negative. So whatever R calculates out to, we need to make sure and put a negative in front of it. So we can find this basically kind of using our explicit formula. So we know that A sub 8 equals A sub 1, 6 times R to the 7th. Just using our explicit formula and substituting what we know that A sub 8 is negative 468,750 times 6R to the 7th. Let's take those parentheses out because it's 6R to the 7th. It's like 6x to the 7th or whatever. 6 times R to the 7th equals that. So all we have left is R now. So now it's some basic algebra. We're solving for R because we were able to substitute in for everything else. A to the 8th, A to the 1st, R n minus 1. Since we know this is the 8th, that'd be 7. So all we have to do is solve this. Now we say that, but it's a little more tricky than some of our algebra. So 6R7, we need to divide by 6, right? So we can do that on both sides, and that'll give us R to the 7th. So let's pull up our calculator once again and say, okay, if we have 468,750, and it's a negative number, and we divide that by 6, negative 78125 equals R to the 7th. So now we're looking at it and going, okay, that's R to the 7th power. How do I get R? That's not as useful as I hoped it would. Can we find R when we have this number is R to the 7th? We can. Think about it. If we had x squared equals 36, right? It's like, well, this isn't x, and we're trying to find x. Well, since this is squared, we take the square root of both sides. And so we get x equals either plus or minus 6, right? Because we took the square root. If this was x to the third equals 8, we would take the cubed root and say x equals 2. It's the cubed root. So taking that concept over here, we have to take the 7th root of both sides. Like, oh my goodness, the 7th root. Well, you can run into some problems because looking at this calculator, it'll take square root, and I can raise something to a power besides 2. I can square it, or I can raise it to a different power, but I don't see a way to take a 7th root.
You can do it in Desmos.
You can do it in Desmos. That's right. So you may need to use a different tool besides the basic calculator that's on there. So let's go to Desmos. We'll pull Desmos over here. Desmos calculator. So yeah, go to an online calculator and have something tricky like that that your calculator doesn't happen to have it. Let's see if we type this in here. If it just lets me type, because it's not being cooperative. There we go. 7th root of, I'm just typing it like this, just straight out math, negative 78,125. Let's see what it does if I just do it that way. Oh no, it makes all this other stuff there. It does it like that. It's adding stuff to it somehow. All right, what other options do we have on there? I don't know that I've done this in Desmos.
Yeah, there's at the bottom, on the bottom left.
Oh, there we go. That's what I was looking for.
And then over in, yeah.
Functions. And I click it, it's waiting. Okay, let's see what we have here. We have lots of options in Desmos here. There it is. See that? It's got a number up there where you can say, I want the 7th root. Let's get rid of all these things here. I want the 7th root of this number. And so you tell it the numbers. 78,125. And that gives us, it's a negative 5. So yeah, so you go here, go to the functions, hesitate, and you go down far enough, and there it is. Nth root, the nth root. So you can decide what n is. If you need just the square root, just make n a 2, because it would be the square root. So whatever root you're needing of can be done right there with nth root. All right, very nice. So negative 5 is our answer. So let's take that. Now we know r is negative 5. So from that point, it's easy to go and figure A14. A14 equals A1, which is 6, times r times n minus 1. R is negative 5, raised to the power of 13, right? N minus 1. Since n is 14, n minus 1 is 13. So that we can do. That we can do in either calculator, really. We can do that on here. Because this lets us take a number and raise it to a power. So if we take 5 as a negative, negative 5, raise it to the power of, see, it's a little to the power of, and we need to raise it to the 13th power. There's that number. And then we need to multiply it by 6. Let's see, multiply it by 6 times 6. Notice when I have this, I do what's in the parentheses first here. It's just easier to raise something to a power first on your calculator and then multiply it by a number. So there's our answer. It equals negative 7,324,200, no, 7 billion, sorry, 7,324,218,750. Big number. A14 is a big number when multiplying by negative 5 each time. Even though we just started at 6, it becomes a big number. So these formulas are very useful, because if we use the other formula, we'd have been calculating times -5 times -5 as the numbers are getting bigger and bigger and bigger and bigger, like having the explicit one to jump straight to it. You just have to make sure you know how to get to R. So, all right. Let's look at that's basically lesson 5.03. That's 5.03, geometric sequences. So now let's look at, get that over there, 5.04, which is geometric series. Geometric series. I'll sharpen that pencil already. We're using up some pencil today. So this works just like the arithmetic series did, where we're going to find the sum, the total of adding up an entire sequence. All right. So if we have a sequence, let's just say 2, 6, 18, etc. All right. 2, 6, 18, etc. So obviously our R here is just 3. It's just multiplying by 3 each time. 3 times 2 is 6, 3 times 6 is 18, etc., etc. And we want to know the first 12 terms. The sum of the first 12 terms. If we took the first 12 terms and add it together, 2 plus 6 is 8, 8 plus 18 is 26, and continuing on to the first, oh, wait a minute, I said 12 terms, S sub 12, the first 12 terms. We need some formulas to be able to do that, right? There's 2 different ways to do that. So let's see if we have, again, we need A sub 1 would be in something you need R, you need to know what N is, of course, A sub N, and the sum of N. So here's one of our formulas that we can use. A1 minus A sub N times R, 1 minus R. Notice this is a little more complicated than the arithmetic series. So for this formula, what do we need to know for this S sub 12? We need to know what the first term is. So A sub 1, which is 2. We need to know what R is, which is 3. And we need to know what A sub N is. We need to know what A sub 12 is. But we don't. So this would be like the recursive type, where you have to know the one before it, or you have to know the ending one. Same type of thing. You have to know the ending term, which if you have that already, then this is the formula we want to use. In our case, we don't have that. We can go back and use our other formulas. You know, if we want to go find it, we can go back and find the 12th term. But let's assume that we're not going to do that, or we don't remember that formula. We don't have it in our notes for whatever reason. What's the other option on that? So here's our other option. I'll put it over here. S sub N equals A1 minus A1 times R to the N over 1 minus R. R to the N. Oh, that's a little different. So let's see, what would that mean here? So it'd be A sub 1 minus A sub 1 times R to the N, R to the 12th, 1 minus R. Since we know our N is 12, that would be R to the 12th. So let's substitute what we know in for that. A sub 1, well, that's 2 in our case. 2 minus 2 times R is 3, 3 to the 12th power, 1 minus R, 1 minus 3. which is -2. Okay. Well, let me highlight these formulas again. Remember, when we see the S, that's always the sum. It's adding all the numbers up into whichever term you're using, which we're stopping at the 12th term. So we're adding up the first 12 terms of this geometric sequence. Now we just have to do the math. So let's do what's in parentheses first. 2 minus 2 times. Let's calculate 3 to the 12th. Go back to our calculator. We want 3 raised to the power of 12. So that's 531,441. All over -2. So S sum 12 equals 2 minus, okay, so what's that times 2? Times 2. 2 minus 1,062,882. All divided by -2. Okay, let's do this in our calculator. 2 minus 1,062,882. So what does that equal? That's what that equals. And then we divide that by -2. So adding up the first 12 terms, it'll end up 531,440. There we go. That saves us a lot of work of finding what those first 12 terms are and then putting them all on the list and adding them all together. We can use this formula and jump straight to the answer. Again, if we knew what the 12th term was, we could use this one. So let's calculate that and look at that option. All right, so we want to know this. So let's write our formula over here. A sub 12 would be A sub 1, which is 2, times R to the n minus 1. So 3 to the 11th. So that'll tell us exactly what the 12th term is. So bring our calculator back up. 3 to the 11th power times 2. So A sub 12 equals 354,294. So there's what the 12th term is. So let's use this formula now and try to figure that out. Let me move that calculator out of our way. So the sum of the first 12 terms would be 2 minus 354,294 times R, which is 3, divided by 1 minus R, 1 minus 3. So that will equal, let's multiply that together first. There's our 354,294. Put it to this side since we're calculating that side. So that's that 354,294. So we need to take it times 3. Times 3. So it's 2 minus 1,062,882 divided by -2. Well, look at there. That's the same calculation. So it's obviously going to give us the same answer. So you can do it either way. You can do it either way. You can just go clean with this formula right here, or you can go back and calculate what is the 12th term, so I can use this formula. There's the 12th term, so I will substitute in and use this formula. Either way, we will get to 531,440. So that is lesson 5.04 in a nutshell, basically. It covers those two different equations to figure out a series, which is adding up all of those terms of the sequence. And so using either one of those formulas will save you a lot of time there. So it works a lot like the arithmetic sequences and series. You have the formulas. You have two options for each one for either just figuring out a term in the sequence or figuring out the sum of the whole sequence. Two formulas to use. One if you know the last one if you don't know the last one. You just need to add them all up. With the arithmetic, is if you know the one before it, you can find the next one. Or if you don't know, you have a formula, you can jump straight to it either way. So the thing is to practice, because the formulas get a little tricky. It's not too bad if you just substitute everything incorrectly and then use the order of operations to do things properly. You shouldn't have any trouble. But the more you practice, the easier that gets. That's math ever since kindergarten. The more you practice your times tables, the easier your times tables get. All right. So same thing. It may look crazy now with all the A's and the R's and the N's and the D's, but the more you do it, it's like, oh, okay, yeah, just put that number, got it. So, all right. If you have any questions, I'm happy to entertain them. Otherwise, I will let you go enjoy the rest of your week, since I won't see you again until next Monday. Are we good?